section 1 of day 2. This is going to be more word problems for you guys and writing equations and finding the percents. Okay? So yesterday we talked about the exponential growth and decay models. The growth model, remember, was f of x equals a 1 plus r to the x, or t I think we used yesterday, right? And then f of x equals a 1 minus r to the t. Which one's growth? Which one's decay? 1 plus r is growth, so the other one has to be decay, right? Now, when you are reading this stuff, make sure you look for keywords that will say population decreases, population increases. Then you'll know if it's growth or decay. Increase, we're growing. Decrease, we're decaying. Okay? So here's what's going to happen on the first type that you're going to see today is I'm going to read you a passage. Let's come up with the pieces. Now, I don't know if Mr. Cunha showed you this part though. A for these stands for the initial amount. Okay. Just double checking. And what's R for? Rate. And what's T? Time. Good. All you're going to do is plug in the missing pieces. You're going to fill in the facts that they give you, and then from there, you have your equation. Okay? So here's what it says. In the year 2000, the world population was about 6.09 billion. During the next 13 years, the world population increased by about 1.18% each year. Come up with your equation. That's the first step. So, are we a growth or a decay? Why? Yeah. What was the initial amount? 6.09. What was the rate?
1.8%.
Close. 1.18. So when you make 1.18% a decimal, how many places do you move it over? 2. Which way? Good. So what is that? 0.0118. And then T. Now, over the last couple hours, just so that you guys know, there's been some people getting them wrong because they're trying to put, I said that after 13 years, it was that percent. So they're trying to put 13 in for T. No, you don't have to. That's just telling you it took 13 years worth of data in order to come up with that percentage. Okay? You're trying to make a generic statement as far as how to figure out the world's population. Now, what's 1 plus 0.0118? And you just came up with your equation. That's step 1. Okay? Then after that, it'll say things like this. Estimate the world population in the year 2005. When did it start? I started in 2000. Now I want to know how much it is in 2005. So what number do you put in? 5. So 6.09, 1.0118 to the 5th power. That's a calculator busy work problem. That's what I call those. So there's nothing in order for you to really solve. It's just plugging it in. Now, what do you guys mess up? You mess up decimal points. Make sure you put your decimals in the right position. So, what do I get? 6.46 billion. Why did I attach that label onto there? Because we're referring to in billions. In the reading, in parentheses, it would have said in billions. And that's exactly what page you were asking about on the other one. how you know. Okay? What do you think so far, you guys? Now, third part, just like you did for 21 and 22, it's going to say, estimate the year when the world population hits 7 billion. So, you have one of two options. Option A, you can put this equation in for y, and then use the trace feature on your calculator to find when y is equal to 7, or close to it as possible. Or you can do what I showed you just a few minutes ago, and that's put this as y1, the other one, y2, you put a 7. Where did I get the 7 from? Because it's 7 billion is the population we want to know. So, if I do that, thanks Vanessa, I'm going to steal yours. So I go to y equals and I type in 6.09 parentheses 1.0118, close it, caret, x. And the other one I hit 7. And then when I go in there and I zoom 6 it, just because I don't know what it is, here comes my curve. And there comes my 7. Now, just for you guys to see this, on the window that Vanessa has, her initial window of 10 in every direction, it does not actually hit each other. So what happens a lot of times with these calculators, if you don't see the intersection, it will say error, no sign change. So which way should I move the window? I'll give you 4 choices. Do I need to move up, down, left, or right? This curve is going upwards, and the other one's a straight line. So which way should I go? To the right. How far to the right do I need to go? I don't know. It's a crapshoot. In order to move it to the right, I'm going to adjust the x maximum, which I'm going to just go 20. We'll just see if it works. Okay, Vanessa? Okay. So once I get that on there, is that going to hit on there, Vanessa? Okay. You bet. All right. Bet. Okay, so did it hit? Did the curve hit the straight line? Yeah. So once I see that the curve hits the straight line on my screen, now what Nick said was to do is he put second trace, option 5. Remember when you do the intersect feature, when you get it on there, if you only have 2 curves in there, all I got to do is hit enter, enter, enter. How many years did it take, roughly? 11.9 years. Okay, so almost 12, right? But here's not the answer. Okay, in about a month and a half or so, you guys are going to be taking an ACT test for the majority of you. Here's the bad part. This question said, in what year did the population hit 7 million, not how many years. So if I put 11.9 or roughly 12, that's really good that you found that, but you didn't answer the question. Part A might say 12, Part B might say 2012. Which one's right? 2012. Right, so be careful. Make sure you answer the question. That's how you're going to do Part B, or C, I mean. That's very, very much the same as what we did yesterday. Okay? That's how you do the first one, just like that. Then, the second one. Here's what it's going to say. The amount Y in grams of a radioactive isotope chromium-51 remaining after T days is represented by Y equals a 0.5 T to the 28, or T over that. I wrote it right, I just said it wrong. Raised to the T divided by 28. Where A is the initial amount in grams. What percent of the chromium-51 decays each day? So we're trying to find the percent. Very similar to this last problem where I found that it was, or that one right where we were talking about 3% increase. Now we have to do the same thing here. Here's how you set this up. If you have a fractional exponent, like this one does, and they will for this problem, what I want you to do is split that up. So if it's t over 28, t over 8, t over 2, t over 50 million, whatever, you do this. 0.5, 1/28 times t. What you do is you rewrite it as a fraction times by the t. Okay? So whatever the bottom is, stays on the bottom. All right? So whatever that number is on the bottom needs to be on the bottom. Okay? Now, here's what I want you to do next. With your calculator, somebody take 0.5 raised to the 1/28th power. What'd you get, Luke? 0.975. If I go 3. Did everybody else that did it, did you guys get that too? Okay, again, when you do that with the caret, I would go 0.5 caret and then parentheses 1 divided by 28. That's how I would do it. Okay? Everybody still good? Now, it said in the reading, let me read it one more time. Here's what you got to find. What percent decays each year? So which formula am I going to use? The 1 plus r or the 1 minus r? Exactly. This number is in the same position as 1 minus r. That's okay. So what I'm going to do is I'm going to put 1 minus r and set it equal to 0.975. Solve for r. How do I get r by itself? Subtract 1. What's 0.975 minus 1? Negative point what? 0.025. 2 negatives should make it a positive, so that's r equals 0.025. Now when we report the rates, what do we usually report them as? Decimals or percents? Percents. So when you want to make that back into a percent, which way do you move the decimal? How far? Good. 1, 2. So how many percent is it? 2.5%. You have a problem that's exactly like that. So the first thing that you guys do again, you split the fraction, and then you raise whatever number is inside there to that power, and then set this number equal to either 1 minus r or 1 plus r, depending on if it says growth or decay. And then solve for r. You guys okay with that? The last type. This formula is used in banking. Yesterday, and I don't know the answer for this one because I wasn't in here, but yesterday, did Mr. Cunha ask you guys if any of you have savings accounts? Okay. And quite a few of you, do you have them? Okay. If you want to know how much money is in your savings account, this is the formula you would use. This formula is for savings accounts. Okay? So what you're going to be given for this is you're going to be given all the information. We're just going to figure out how much money is in your account. So what A stands for the amount in the account. Okay, that's what A stands for. So that's going to tell us how much money is in there after X amount of whatever. P is principal. What's principal? It's like the what? Never mind. There's a couple different things for principal. Principal could be the people downstairs, or it could also be the amount of money you start with. That's what principal is for us. Principal is the amount of money that you start with. Okay, and I'm going to give you a scenario there. The next part along that, that's a 1. Okay, that is a 1, not an L. That's a 1. What's R stand for? Rate. It's the same thing. N refers to the number of times a year. So for those of you that have savings accounts, do you know how many times a year the interest is compounded? You don't? Okay. I have 2 different savings accounts. One I have at Gate City Bank, which is compounded quarterly, which means 4 times a year they give me interest. I have one at First Western that's monthly, which means every month they give me interest, or 12 times a year. There are other options like daily. How many times would daily be?
Once every 24 hours.
Once every 24 hours, which how many times a year would that be? 365 times. How about semi-annually? Twice a year, or every 6 months. How about annually? Once a year. So all those keywords are going to come out. If you notice, I kind of have some of those over there on the board because for consumer math. I'm leaving those up there. So if you ever have to wonder, I have some of them up there. I don't have semi-annual and I don't have annual up there or daily, but I will. Then T stands for time in years. Okay, so that's what it is. 1 plus R over N raised to the N times T. Now, where you're going to get in trouble is going to be something like this, where it's going to say time is after 6 months. And you're going to put the number 6 in there for T, and you're going to be all sorts of wrong. What number would you have to put in for 6 months? Half a year or 0.5. Now, here's the scenario that we're going to use. Okay? Here's what they're going to give you. Something like this. Sean graduates this year. At graduation, his grandparents were so happy that they decided to give him a $2,000 present. Sean, smart enough with his money, decides to take that $2,000 and put it in a savings account for some time in the future. So what I'm giving you is when I said that, $2,000 is the principal. He elects to put it into a savings account at First Western Bank in Minot, North Dakota, which the rate is 0.25%. I know that because that's where I have one of mine at. Where they compound interest monthly, which means 12. After 10 years, Sean needs that money. So how much is the time? 10. How much money does he have now? So what I'm going to do is I'm going to plug in all my numbers in, and let's just see what we get. It becomes a calculator busy work problem, honestly. Okay? So it's going to be something that looks like this. The amount in the account is what we don't know. We know that we started with $2,000. 1 plus. We know the interest rate is, what's the decimal for 0.25%? If it's 0.25%, what's the decimal for that? 0.0025. Good. Just move it 2 spaces over to the left, remember? And we said that it was done monthly, so what's the number for monthly? 12. And then we also said that that's the number 12 because that was also monthly, right? Those two numbers should be the same, by the way. And then you times that 12 up in the exponent by how many years did we say you needed it after? 10 years. Now, honestly, with your calculators the way they are, you type this, 2,000 parentheses, 1 plus parentheses, 0.0025 divided by 12, close it. Remember what I said about parentheses or fractions? I always like to put them in their own. That's how I do that. Then I go caret, and depending on the caret that you have, if you've got a newer calculator, you will not have to put that in parentheses. If you have the older calculators, you will. And then parentheses 12 times 10. Close it, enter. How much money does Sean have now? And how many cents? And 62 cents. Okay? Now, realistically, Sean made $50.62 over the course of 10 years. I know it's not much, but it's because it's savings accounts. Savings accounts don't earn much. Okay? In last hour, they decided to do it after 40 years. Same numbers. It was just 40 years instead of 10. And then the account had $2,210 and some odd cents. Now, when you think about that though, did Sean have to do anything in order to earn the $50.62? No. All he had to do was open a savings account, which does not cost him any money, put that money in there, and just let it sit. Now, with savings accounts, if you put more money in there, what's going to happen to the interest? It's going to go up, because the more money you have, the more interest you make. Okay? Me personally, how I have mine set up at Gate City or First Western, I have my paycheck that comes out of mine at State, and I automatically put X amount of dollars from that paycheck into my savings account. It's built-in savings program, so that way, like during Christmas time, I have got extra money for presents or whatnot. So I don't have to save on my own. It just automatically comes out of my paycheck. You can do that too. If you did that on your jobs that you work, you could have that deducted right from your paycheck if you'd want it. Okay? So, just so that you are aware of it, that's the last few problems. You plug the numbers in and see what you get. What do you think? So on page 300 to 301, we're... Did you write the numbers down? 23, 27, 37, 39, 41, and 43. I think it's 43 now, 42. Yeah, 43.